students, today we are going to see important topic that is biomolecules. Biomolecules are very important for our life process only. Okay, biomolecules, a molecule produced by the living organism. It's called biomolecules. Biomolecules are proteins, vitamins, carbohydrates, lipids, nucleic acids. These are all we can say biomolecules. Which is the most abundant biomolecule in the nature means carbohydrate. How do we get that carbohydrate? In nature, plants synthesize carbohydrate. This process is called photosynthesis. So you know photosynthesis from smaller classes onwards. You have gone through photosynthesis. So in nature, plants synthesize carbohydrates. This process is called photosynthesis. Okay, carbohydrates are organic compound. It consists of carbon, hydrogen, oxygen. So what are the things which will be in carbohydrate? What are the things are available? Means naturally it is carbon, hydrogen and oxygen. So the empirical formula it is CXH2OY. So carbon, hydrogen, oxygen. So this is the empirical simple formula. Okay. Now next one. So we can say it's a hydrates of carbon. Chemically, carbohydrates are polyhydroxyaldehydes or ketones. So generally, what is the functional group present it is there means it has to be aldehydes or ketones. A substance which on hydrolysis gives aldehydes and ketones, which is called carbohydrates. That's what I just mentioned. A substance which hydrolysis produces aldehydes and ketones are called carbohydrate. So, what is the functional group present in that carbohydrate means? You can easily mention that aldehydes and ketones. Hope you got that idea about the introduction part. Let us go for the classification of carbohydrate. Yes, now we are going to discuss about carbohydrate classification of carbohydrate. It's very important question. Okay, now based on the number of simple units present in the molecule, we can be divided into three groups. That is actually what it is: monosaccharides, oligosaccharides, polysaccharides. Monosaccharides are simplest carbohydrates. Okay, further cannot be hydrolyzed, so that is called monosaccharide. So what are the examples of monosaccharides means? Glucose, fructose, galactose. What is the general formula? CnH2nOn. So this is the simple way we can identify. Now the second one, everything comes under hydrolysis only. So monosaccharides which cannot be hydrolyzed. But here oligosaccharide, that means it is hydrolysis. Okay, which on hydrolysis gives 2 to 10 monosaccharide units. Example, sucrose, lactose, raffinose. So these are all comes under oligosaccharide. That means this can be further hydrolyzed. Okay, now this can be further classified into disaccharide and trisaccharide. So disaccharide, what is the general formula of disaccharide? CnH2nOn minus 1. Now, which on hydrolysis it gives 2 monosaccharides. Now, for example, sucrose, it's a disaccharide. So what are the product comes through hydrolysis? Glucose and fructose. Lactose is a disaccharide. What are the products it's coming after hydrolysis? Galactose and fructose. Now next one, trisaccharide. What is the general formula? CnH2nO n minus 2. Now which on hydrolysis it gives 3 monosaccharides. So what is the example? Raffinose, galactose, glucose and fructose. So these are all comes under what it is? Oligosaccharide. See, oligosaccharide, as I mentioned, 2 to 10 monosaccharide units. So that means these are the examples. Like sucrose, it gives what it is? 2 saccharides, that is 2 monosaccharides, glucose and fructose, when it is going on hydrolysis. The same way, lactose, it gives what it is? Galactose and fructose in that way. So further it is trisaccharide, tetrasaccharide, pentasaccharide, like that it will be going on. Okay. So hydrolysis, it gives that many compounds. Okay. That many monosaccharides are providing. Come on, let us go for the under hydrolysis only. So which on hydrolysis gives a large number of monosaccharide units? Okay, now example, inulin, starch and cellulose. These are the three units. Three examples are there. This also further hydrolysis it gives, because it's poly more than one, it is number of units are there. So on inulin on hydrolysis it gives number of fructose units. The same way starch, number of alpha glucose units. Then next one cellulose, on hydrolysis everything comes under hydrolysis only. Further hydrolysis you are getting number of beta glucose units. So these are all what it is, classification of carbohydrates. Hope you're clear with it, because in that one more question, two more questions are available. So if you want, you can take that screenshot. Hope you understand. Now, the next question, classification of monosaccharides. So, classification of monosaccharides, I would like to bring it here. Sucrose, hydrolysis, it gives glucose and fructose. Okay, glucose, what is the formula? Here, C6H12O6. The same way, fructose also, C6H12O6. Now, both are same formula, but different functional group. That is what I bring it to this point to you. Okay, classification of monosaccharides based on the functional group. So the functional group will be vary. So sucrose functional group aldehyde, fructose functional group ketone. Okay, but here the formula is same, C6H12O6, but the functional group will be vary. Now, how to identify the functional group? That is what I just bring it to you. Okay, now aldehyde, it is a functional group, so that is aldose. Aldose, it is what it is, glucose, and galactose also will be the same functional group, what it is, aldehyde. Okay, now this we can say aldopentose. How many carbons are available? 6 carbons are there. And then sixth carbon, it is an aldehyde functional group. So here 1, 2, 3, 4, 5, 6. How to remember, ma'am? This is like HOH zigzag like that. You just remember this is glucose. What is that formula? CHOH, carbon it is there like a what it is, backbone. Okay, HOH, OH, HOH, and CH2OH. The last point carbon it is CH2OH. Whereas here, you just see the same carbon 1, 2, 3, 4, 5, and 6. Now, third and fourth carbon will be OH in the right hand side. Okay, so you just remember, but here it is a zigzag. You just remember in that way. First and foremost, I wanted to mention here aldehydes of glucose are aldopentose. So 5 carbon includes what it is, aldehyde functional group, that is that is also a carbon includes. So aldehyde functional groups we can mention. So here aldopentose, whereas here ketones, fructose or ketose functional group. So we can say ketohexose. Okay, now that means here 6 carbons are there. That means ketohexose contains 6 carbon atoms include keto group. That is what I just mentioned, C double bond O. Okay, now here also the same, 1, 2, 3, 4, 5, 6. Okay, now second carbon always keto group. For here first carbon it is aldehyde, but here fructose second carbon it is a keto group. And here also the same. Third and fourth, you see HOH that side sorbose, and here what it is, fructose it is OH. Here just you remember, usually glucose and fructose only they'll be asking. Suppose if they are asking about sorbose formula, you just see, imagine this formula, then you go for the zigzag. Okay, you see, hey, OH, H here, HOH. Here, just here, HOH and OH here. Rest of that, it will be same. Okay, hope you're clear with this classification of monosaccharides. Just to identify the functional group. Functional group, glucose and fructose only. So what are the glucose? Glucose contains aldehyde group. So that is aldopentose. Whereas here, fructose contains what it is? Ketohexose. That is very important point to be noted down. If you want, you can take that screenshot. Next one, classification of monosaccharides based on the number of carbons atom present into that. Okay, minimum it has to be 3 carbon atoms. Okay, now in that first one, triose, next one, tetrose. So minimum it has to be 3 carbon. Then only we can go for that monosaccharides formula. Okay, here triose, here glyceraldehyde. Glycerol you know very well. Glycerol formula, 3 carbons will be there. CH2OH, CHOH, CH2OH. Whereas glyceraldehyde, CHO, CHOH, here CH2OH. Yes, come on. Next one, tetrose, 4 carbon. Here CHO. Everywhere aldehyde I brought it. Okay, CHO, HOH, HOH, and CH2OH. Okay, now the next one, pentose, the same way. CHO everywhere, left hand side, right hand side, in that HOH and CH2OH. You remember the middle one, it is like a backbone. Then left and right hand, in that way you can identify. Now hexose are famous glucose. CHO on the top, CH2OH at the bottom. Okay, now here HOH, HOH, and HOH. Hope you remember that fructose point where it has to be that OH by the time I have mentioned that time. Okay, now next one here, heptose. Heptose here they brought it keto group. So here keto group CH2OH, here 7 carbons will be there. In that second carbon keto group will be there. Usually keto group will be second carbon. And the first carbon it is aldehyde only the first carbon. Usually second carbon only keto group will be coming. CH3, CO, CH3 keto group. So it will be middle part of the group only. Okay, now you remember heptose here CH2OH, C double bond O, here full 7 carbons are there here. OH, AH, HOH, AHOH, and HOH, CH2OH. This is pseudoheptulose. Okay, so these are the points we can bring it. These are the examples only for that classification of monosaccharides based on the number of carbon atoms. I just brought it to your examples only. Okay, now next one. Here, the next classification is classification of carbohydrates based on the taste. Okay, here, what are the two types of classification based on the taste? Here, sugars, non sugars. Okay, sugars, it is a sweet taste. Non sugars, there is no sweet taste. Okay, now how to identify? Here, monosaccharides and oligosaccharides are sugars. Okay, how to identify? It will be a crystalline solids and it will be soluble in water. Okay, non-sugars, it is no taste. Amorphous, you know amorphous, it is a powdery form, talcum powder like it will be there. And of course, it will not be soluble in water. Okay, that's all about the taste of classification. Now here, sugars can be classified into 2 points, that is reducing sugar, non-reducing sugar. So reducing sugar, these are the sugars that reduces. So how it is reduces? Why? What is the reason it reduces? I'll tell you. Okay, tolerance reagent reduces to black ppt of silver. Fillings reagents into red ppt of cuprous oxide. Benedict reagents into red ppt of cuprous oxide. Okay, now what is the reason it reduces? Because these sugars contains OH group on anomeric carbon. Okay, hence they can be present in alpha and beta form. What is anomeric form of carbon? Anomeric carbon, it is nothing. Carbon in a sugar which contain aldehydes and ketones in the open chain form and stereo center in the cyclic form. So this is called anomeric form, that is alpha beta form. Okay, now whereas non-reducing sugar, the name only which will not reduces. Okay, of course, do not reduces these reagents. This through this reagent it cannot reduces. Due to that, not contain free aldehyde and ketone group, hence they do not exist alpha and beta form. Hope you're clear with it. They may ask the question, what is anomeric carbon or what is reducing sugar? Give examples. So in that way, they may ask the question. Hope you're clear with it. Let us go for the next question.